thank you very much, and thank you, Lama, for the nice introduction to the connection to Hub Free. So I would like to start from the end. So in the last, at the end of the presentation of Lama, we were talking about a possible application. So I will go from the possible application back to the connections to Hub 2 and Hub 1. And now, regarding application, sorry, but let's see if it works. Yeah. Yeah. Regarding application, they will be related to automotive, and we have two partners that are dealing with this application, in particular for electrical vehicles, electric motors, Ford and Vitesco. Then there would be an application related to robotics, in particular fast exchange of end effectors of robots, and one application related to energy generation from sea waves. Now, this is the idea to go from the end, right, from the application, and the idea is that we will be able to produce a certain amount of magnets. Obviously, this is just for demonstration purposes, but it's not a very small amount. It's an amount that is already showing the possibility of introducing these magnets in products and analyzing the impact. So as you see, there will be a few hundreds of kilograms of magnets produced at the end of a project. And the possible application, as I said, are related to various fields. In particular, Ford will be testing on motors that are creating cooperation with that motor. Stellantis will mostly deal with the characterization of what are the needs for possible application in automotive field. Vitesco will work on new concepts of motors that can be used with newly designed magnets. And then we'll have ETRA that deals with the application related to robotic hand effector exchange, and Primum that demonstrates the use of magnets for the generation of electricity from the waves. So these are the application. And then if we go to the concept of the Hub Free, we go back from the application back to the processes that help to create the magnets that are needed for the application. So we deal with different types of magnets, so sintered magnets, obviously, but also bonded magnets, and let's say 3D printed magnets of different types. So clearly going backward, then you have the various processes that are needed, right? So this slide is showing the connection among the different processes. And so if you are to the right, you tend to go to the final magnet. To the left, you have the previous steps that are needed to reach this goal. In particular, in Hub Free, we are dealing with some innovations that are specifically created during the project, and they are related to the creation of the magnets as well as to the creation of the material that is needed for the magnets. So we will deal with some of these innovation while dealing with the various steps, but each activity is related to some innovative technology, let's say. So in fact, one problem with the magnets is that not only we don't have the rare earth, but also we miss some important processes that at the moment are mostly done in China. So creating these technologies is a goal, is a very important goal in itself. Now, moving backward from therefore the application, we have different technologies in order to make the magnets, right? The first one is clearly the sintering, and we have different contribution from MagResource, Magnosphere, and NIMP. They will produce sintered magnets in different ways. Basically, mag resource in particular will deal with the magnets created from hydrogen decrypitation and degassing. So they will come directly from what has been explained by Lama in Hub 2. Magnosphere will deal with selective laser sintering of powders, and NIMP will process magnets as melt spoon ribbons of various sizes. So they are different processes. They all produce sintered magnets, and they are innovative, and they are the possibility to create for Europe new innovative technologies and machines for this goal. Going to another possibility is to create magnets through 3D printing. So here the idea is to create a prototype print head that will be able to deal with the filaments, combining the bonding and the magnet, and therefore you are able to deposit in various shapes and create magnets of desired geometries. Another process, as I said, is the bonding magnets, so injection molding basically. And here we have 3 partners that are dealing with this: EMA, Collector, and Politecnico in Milano, and they will deal with different types of a final product, and Collector in particular is dealing with high volumes of bonded magnets, materials compounded from 2 powder streams, and EMA will consider the opportunity of having much more homogeneous material and composition, and Politecnico in Milano will deal mostly with the micromagnets. All these magnets will be produced by injection molding. Okay, so this is for the final magnet production, and then in order to do that, you need the material, right? And for doing this material, we have different processes. Again, some innovation here too. In particular, metal pine will work on powder created from wire. So the process takes the recycled powder, it creates wires of this powder, and then creates a powder, spherical powder. So in this case, the distribution of the size is very, very centered, and variation is very small. So that is a particular process that is innovative and has not been used in the past in this area. Mag resource will deal, as we already said, with the preparation of powder from hydrogen decrypitation, and then using this powder to create new magnets. And then we'll have the possibility of using particular processes for polymerization by chemicals from EMA and Collector, so that the pelleting step will be improved. That is obviously for bonded magnets. Going even backward, then we have the problem of defining pure metals from oxide, and therefore we have oxide reduction technologies. And here we have 2 approaches: filler, pilot. It will be based on chelating composition, and processes based on clean chemistry. Obviously, in this case, we are talking about small quantities. It's more to demonstrate the possibility of doing this. And then Pensana will work mostly with known processes, which is basically electrolysis. But in this case, there will be introduction of innovation in the electrolyte, in the electrodes. So this will improve the performance of the process and the efficiency of the process. So as you have seen, this part obviously is the one that then relates to Hub 2 and Hub 1 conceptually. because in fact oxides are taken in input, not necessarily in terms of quantities, because obviously in hub one we are talking about tons of material. Here we are talking about few kilograms of material, especially for filler, and a bit more for Pensana. But the idea is that conceptually these processes are related in a chain, and it shows that it is possible indeed to follow this chain. So this is explanation, let's say, of the main activities what we are doing in work package 5 that directly relates to hub free within the project. So with this, I would like to stop. I don't know if there are questions. I'm really happy to try to answer.
There is one question, Tullio.
Yes.
Regarding this assembly process, are there strategies to separate magnets from rotors?
Yeah, sure. But that separating is in hub 2. Actually, Lama has already presented the idea of separating magnets from rotors of electrical vehicles. I think the question is about that, right? And so we as Politecnico are involved in that. So maybe I can say something about that. So basically, we have a new pilot line that is able to separate magnets from rotors in an automatic way. That is the main goal. So automating the process in order to make it possible to make those processes in Europe. Therefore, I mean, where we have high wages and we need automation in order to be able to be competitive. So that I hope that answered the question, but maybe Lama, you can add to this point.
Lama, are you still with us?
Yeah. Yes.
Okay.
I'm here. Thank you. Yeah, thank you, Tullio. So, is there any complementing information you may need, Xiaozhong? Okay, so I think, Tullio, you
I guess
answered
not.
the question. Yes. Thank you.
Okay. So now we have the hub 1